profoundly alter our world in general and the weirdly Minnesota-heavy world of 1990s cinema. To be clear, we're not changing the tilt of the Earth's axis of rotation relative to the sun. We're imagining that the Earth's surface is slid around by 90 degrees, putting the land that's under our current poles on the equator, and we'll pick the stars at the South Pole. Let's imagine that this alternate Earth develops over millions of years, giving time for ecosystems and climate zones to settle out. Where would the deserts and forests be? And where would you go for a sunny beach vacation or to chase a tornado? This stuff is complicated, since climate depends heavily on the details of ocean currents and atmospheric heat circulation, but we can make some broad sweeping speculations based on general climate physics. The main driver of our weather and climate is the sun, which delivers more heat at the equator than at the poles. So hot air rises at the equator and flows poleward over our heads. Then cooler air moves in across the surface toward the equator. This circulation is called a Hadley cell. For various complicated reasons, Earth doesn't have just a single atmospheric cell in each hemisphere, we actually have three: Hadley cells, Ferrel cells, and polar cells. Let's assume our rotated world has the same situation going on. This means it would have temperature extremes which are similar to ours. Here's what a map of our rotated Earth looks like. We'll add some ice and permafrost near the poles and in mountainous areas. Next, we should fill in some green areas and deserts. The locations of these depend heavily on rainfall, so we'll need to sketch out some winds. Because of the Coriolis effect, the surface winds in a Hadley cell flow not just toward the equator, but from east to west. In the temperate zones, the prevailing surface winds are west to east, and at times there are also east to west winds circulating around the poles. So let's fill in some wind patterns, keeping in mind that in reality things would be further complicated by land interactions and the locations of persistent high and low pressure systems. The rising air at the equator carries moisture from the ocean, which then condenses into rain, so tropical areas are usually wet and thick with growth. Sinking air is cool and dry, so the land under the outer edges of the Hadley cells tends to be arid. For fun, here's a wild guess as to where the hurricane basins might be. And for more fun, here's a guess about what time zones would look like. New York City, notably, stays in the same time zone. Africa is rotated by 90 degrees, with former West Africa becoming tropical rainforest and former East Africa an arid desert. On our Earth, North America has by far the most tornadoes of any continent, but Antarctica is the clear winner. Without its ice cap, it's a bit smaller than we remember, but most of it is blanketed with highland rainforest. There are alpine zones around the mountains to the south and west. The researchers at McMurdo and Ross Island work in a tropical paradise. If any of them decide they miss the frozen wastelands, hey, they can always put in for a transfer to Costa Rica. Now, let's check on how the world's many cities remain comfortably habitable, albeit with some changes. Seoul, Osaka, Tokyo, Shanghai, and New York City are among the least affected cities, with climates roughly similar to their previous ones. Sao Paulo and Buenos Aires cool down a little bit. Their climate is somewhere between that of our old New England and that of our old regular England. I mentioned the impact on 1990s cinema. To explain, let's consider one more scenario.